So the session is being recorded. All right, so let's go over those couple problems that I asked you to look at. And actually the second one is a mimic of your assignment. A life insurance company sells a $250,000 one-year term life insurance policy to 20-year-old male for $350. According to the National Vital Statistics Report, the probability that the male survives the year is 0.998734. So there is a 99.87% chance that the 21-year-old male will not die this year and collect, the 250. Well, actually, it's not going to be him who collects, it's going to be his family. Compute and interpret the expected value for this policy. Okay, so let me show you how to do this. In order to find the expected value, this is the formula: E of x equals sum of x px. Well, you need x and you need p of x. So we need to create this distribution table. X is the money you gain or lose by buying this policy, and p of x is the probability. Okay. Well, the person, if he wants to buy, the policy, he has to pay $350. So if you pay $350, guys, it's a loss. You already lost that money. They won't give it back to you. It's negative 350. Can someone tell me that the probability of losing this money means surviving, not dying? Because the only way to gain money from the company is if the person dies. So what is the probability that the person will survive this? It's given. Do you guys agree it's 0.998734? So you just put 0.998734. Now, this is the bad scenario that the person dies. And if the person dies, his family is going to collect $250,000. But that's not going to be a gain of $250,000, guys, because they already paid $350. So the gain is going to be $250,000 minus $350. So it will be $249,650. And what is the probability that the person will make use of the policy? It's the complement of this. If it is 0.998734 to survive, what is the probability of not surviving? Will be 1 minus this. Just like rain or no rain. If there is 80% chance of rain, there is 20% chance of no rain. And if you do this, you will get, I already have the answers here, 0.001266. Now, how do you find the expected value, guys? Watch. The expected value will be this value of x times the probability, which right here, plus this value of x times the probability, and the answer will be negative 33.50. So on average, if a 21-year-old male buy this kind of insurance, he is expected to lose $33.50 for each year of coverage. All right, which is a good thing. You don't want to gain from the life insurance, because if you gain, that means the person passed away, did not make it. Okay, so that is this question. Now the second question. According to American Lung Association, 90% of adult smokers started smoking before turning 21. 10 smokers, okay, so P is 90%, guys. 10 smokers, so N is 10, are randomly selected, and the number of smokers who started smoking before 21 is recorded. Explain why this is a binomial experiment. Well, it is a binomial experiment because there is a fixed number of trial, which is 10. And the probability of success does not change from one trial to another. It's 90%. And the possible values of X, where X is the number of adults who smoked before they became 21, could be as low as 0, as high as 10. As I told you, X always starts with 0 all the way up to this number right here, which is 10. So it is a binomial experiment. Now let's answer some of the questions there. Use your TI-84 to find the probability that exactly 8 of them started smoking before 21 years of age. Well, remember, guys, exactly means binomial PDF. And if I use the calculator, it's going to be this, and then I'll show you what to write right here. Here's the calculator. You go to second, distribute, scroll down to binomial PDF for exactly. Trials is 10, probability of success is 0.90, and the X value, it says 8 of them. Paste, and the answer is 0.1937. So this is how you answer this question, and here it is. Probability of X equals 8 is 0.91937. Next question. Find the probability that at most 8 of them, and I explained to you yesterday, at most 8 means 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. And the calculator has a feature that can compute this for you. So that will be X less than or equal to 8, and it's a binomial CDF. And how do you do this on this calculator? Yesterday I demonstrated the other calculator, but we'll do this now. Watch. It will be second, distribute, and you need CDF for at most. Don't forget that. Understand the difference between the two. 10, 0.9, it's the success, and the X value, guys, is 8. Paste, and then enter. It's 0.2639, and let me show you what to write here. It is binomial CDF 10, 0.98, 0.2639. When we used to do this exercise on campus and on the test, I used to require students to show me this part here, then write summary of the technology used, which is like this, binomial CDF 10, 0.98, and then finally the answer in order to get full credit. All right. Next question. D. Use your TI calculator to find the probability that at least 5 of them started smoking before 21. Okay, let me show you how I go about doing this. I only have 2 features on the calculator, and I have to use at least 5 means 6 or 7 or 8 or 9 or 10. I mean, guys, if you want to do if you have the time, you can do PDF on 6, PDF on 7, PDF on 8, PDF on 9, PDF on 10, and add them up, and you get the answer, and you would be a perfect answer. But let me show you a shortcut to this. Okay, write from 0 to 10. That's what he wants. We want this. This we don't want. But guys, we can find the probability of X at most 5. 5 and below, we can do it because the technology allows us with the binomial CDF. So this is what you do. You run binomial CDF on this, then 0.9, and then 5. And whatever answer you get, you subtract it from 1, because the rest is going to be what we're looking for. So it will be 1 minus. So this is what you do in the case of at least, guys. You do at least 5, you do 1 minus binomial. Here, sorry. At least 5 of them, I'm sorry. I should have included 5 in here. At least 5, so 5 or 6 or 7 or 8. So we need the 5 to be included there. So we're going to run it on 4 right here. So we need 5, 6, 7, 8, 9, 10. So this you cannot do on the calculator. Anything from a number onward, you cannot do on the calculator. But from a number and downward, you can do it with using CDF. So we'll do 1 minus binomial CDF to 4 and then get the answer. And here's how I did it right here. You can see that, guys. I will PDF this document and email it to you because that will complete chapter 4. Use your TI calculator to find the probability that more than 5. More than 5, guys, watch. More than 5 means 6, 7, 8, 9, 10. Well, I cannot do this on the calculator directly, but I can do the rest, which is 5 or less, which is Binomial Cdf to 5, and then I do 1 minus. You see the difference between at least 5 and more than 5? It's the 5 here and the 4 there. And you do 1 minus this probability, you get the answer. Finally, find the mean and the standard deviation of the binomial distribution. The mean, guys, is NP, which is 10 times 0.9, which is 9. And sigma is square root of NPQ. If P is 90%, the Q is 10%, and then you just do the square root. Any questions there before I go over the assignment? No questions? We're good? All right. Let me go to the assignment now. I will let you know how to submit this assignment, guys, but please get it ready. You can get it ready as soon as today and focus on 5 from today and on. According to the 2015 American Community Survey, 43% of women aged 18 to 24 were enrolled in college in 2005. 15 women were randomly selected. So you can see, guys, I marked P as 43% and you write it as 0.43 and N is 15. Find the probability that exactly 7 of them, so exactly 7 of them, you agree, guys, it's binomial PDF. N is 15, P is 0.43, and then X is 7. Okay, you get the answer. Find the probability that at most 7 of them, at most is binomial CDF, and here X is less than 7. You just run the binomial CDF on 7. So the CDF is for at most. Find the probability that less than 10. Less than 10, guys, means 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So it's 9 or less. So you can run CDF on 9. It means at most 9. So less than 10, change it to at most 9 and run a binomial CDF. More than 6. So you get a lot of hands for this one. More than 6 means 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, guys, you can do a PDF on each one of them and add them up. You'll get the final answer. But the shortcut, more than 7, that's what I want. What is it that I don't want? 6 or less. You can run a binomial CDF on this and then subtract the answer from 1, you will get this one. Okay? Compute the mean and the standard deviation. The mean is NP. The standard deviation is square root of NPQ. N is 15, guys. P is 0.67. And Q is 1 minus 0.67. And then you can find the answer. And this is, again, a summary of what I provided you yesterday with. I will scan this page as well so you can see it. This is what we went over yesterday, the shortcuts and how to do each problem. The only thing that I didn't go over yesterday is what about if he asks you to find the probability of X between 2 numbers and let's say inclusive? Well, that's very straightforward. If he says what's the probability of X between 2 and 4, then including 2 and 4, he wants probability of 2 plus probability of 3 plus probability of 4. So you run a PDF on 2, PDF on 3, PDF on 4, and then just add them up. And if you had the expected value for the probability distribution, guys, is sum of X, PX, if you are given a probability distribution. Remember, probability, each probability has to be between 0 and 1. No negative probabilities ever. And the sum of probabilities equals to 1 always. And that should make a lot of sense to you guys. The sum of probabilities is equal to 1. For example, if it is raining or not raining, if the probability of rain is 90% and the probability of no rain is 10%, well, if you add them up, you'll always get 1. That concludes chapter 4. I did email you a handout for chapter 5, and I'm gonna start with this one. Any questions, guys, before I begin? No questions? Everybody is quiet today. All right, so we define continuous variables. We understand that. It's a total opposite of the discrete variable, guys. Remember that. And a continuous variable has an infinite number of possible values. But in the case of the example that I did in chapter 4, when we say 15 females were interviewed, there are no infinite numbers here. X could be 0 or 1 or 2 or 3 all the way to 15, and that's it, and we're done. Whereas with the continuous case, you have decimals, you have unlimited possibilities. All right. Let me show you this curve here. And this is the distribution that we're going to be working with throughout the semester from now on. The continuous, the normal, the bell-shaped, the symmetric curve. Bell-shaped curve. The mean is right in the center. There is a tail toward the right. There is a tail toward the left. And 99.7% of the data fall within 3 standard deviation of the mean. 95% fall within 2 standard deviations. 68% of the data falls within 1 standard deviation. This is what I introduced in chapter 2. We talk a little bit about the bell-shaped curve. So this is the most important distribution that you will ever learn. And the graph of the distribution is called what, guys? What would you write here? Starts with the letter B.
Bell-shaped.
Bell-shaped, yes. Bell-shaped curve. Okay. What about next page, next paragraph? Properties of the normal distribution. The mean, median, and mode are, they're right here.
Central tendencies.
They are, but what do they share in common?
The middle.
Yes, so then they are all this is the mean, and this is the mean, the median and the mode. So they are what?
The same?
Same, exactly. They are all equal. Okay. The normal curve is bell-shaped and symmetric about the mean. The total area under the curve, guys, is always 100%. So any curve, any probability distribution, all the probabilities have to add up to 100%. So the total curve is 100%. Now, what I'm trying to show you here, you see the tail here, it doesn't touch the x-axis, but when you draw it, the computer is not going to be able not to do that. So it feels like it touches, but it doesn't. So the fourth property of the normal curve, guys, is the normal curve approaches but never touches the x-axis. As it extends indefinitely from the right and indefinitely from the left of the mean. So these are the properties of the normal curve. The normal curve, guys, has a mean and a standard deviation, and I want to show you some examples. There is a mean here, 3.5 in the middle, and the standard deviation, he tells us, is 1.5. Now look at this curve, guys. He says the mean is 3.5. Would you agree that the standard deviation is smaller here? It has to be smaller, no matter what he gives us, as long as he gives us a number less than 1.5. And the reason why, guys, because this curve is more flatter. So the data is more widespread. You see it goes from 0 to 7, whereas here, right here, from 1 to 6. So it's a narrower curve. Narrower curve means a smaller standard deviation. Now look at this curve right here. This curve, it seems like it has the same opening just like this one. So probably they have the same standard deviation, but the means are different. Look, guys, the mean here is 3.5, but the mean over there is 1.5. So the conclusion from these examples that two curves could have the same mean but different standard deviation, or could have the same standard deviation but different means, or totally different means and different standard deviation. So everything is possible. Any questions? So normal curves, two normal curves could have same mean but different standard deviation. Or two normal curves could have same standard deviation but different means. Or the third case, means and standard deviations are different. Different means and standard deviations. Are we good so far, guys? That's very, very important chapter. So it's extremely important to grasp. I'm gonna go as slow as possible to make sure that you grasp the ideas of this chapter. All right, let's go to the next slide or next page. All right. Okay, the question, which curve has a greater mean and greater standard deviation? What do you guys think? Which one has a greater mean? Let's see, I have something in the chat. So A is a greater mean. I do agree because the mean is 15, and for B, the mean is 12. And which one has a greater standard deviation? Without knowing what the standard deviations are, guys, you don't need to know them. B, yeah, that's correct, Allah. And what is the standard deviation? I really don't know, but I know B is flatter, more widespread than A, so it has a larger standard deviation. And these are the answers. Okay. Now, guys, please pay attention to this before we move to the next part. Let me just do this sketch. And I'm gonna do the standard deviation to be 10. So I'm gonna, when you scale 3 standard deviation, 110, 120, 130, and then you go 3 standard deviation down. Okay. I'm gonna ask you a few questions there, and please participate with me in this and answer those questions. If I take this value, my question to you, how many standard deviation is 110 apart from 100? By how many standard deviations? One standard deviation. Okay, great. It is one standard deviation. Let me tell you why, guys. Because the difference between 100 and 110 is 10, and each 10 is a standard deviation, so that's one standard deviation. I'm just gonna put 1 sigma, one standard deviation. What about 120, guys? How many standard deviation is there apart from 100? Okay, 2, very good. 2 standard deviation. This is going to be 3 standard deviation. What about 90, guys? How far apart and as far as the standard deviation from the mean? 1, but from which side? From the left. So how would you express 1 in this case? -1, yes. -2, and -3. What about 100 itself? How far is 100 apart from itself by means of standard deviations? Let me see what you guys think here. 0, yes, 0 standard deviation. Okay, those labels 0, 1, 2, 3, -1, -2, -3 are called z-scores, guys. Z-score of 1 means this number is 1 standard deviation above the mean. Z-score of 2, this number is 2 standard deviation above the mean. So the labeling here is going to change. Instead of X, it's going to label it as Z. And look what I have now. I'm just going to redraw this one nicely. And 0, 1, 2, 3, -1, -2, -3. And if you put this Z, it's exactly the same as the original one with those numbers 100, 110, but using a standard deviation. This is called the normal curve. This is called the standard normal curve. The difference, guys, between the two is the labeling on the x-axis. When you use 100, 110, etc., you use the x value. When you use z, 1, 2, 3, etc., you use z values. This is called the standard normal curve. The standard normal curve has a mean of 0 and a standard deviation of 1. The normal curve has a mean, whatever he says, the mean is 100, and he says the standard deviation is 10. But the standard normal curve always have a mean of 0 and a standard deviation of 1. Mean of 0 means z-score of 0, and this standard deviation of 1 right here. Okay, so let me take you back to the handout, show you this curve here, the standard normal curve. It's a mean 0 and standard deviation of 1. Total area under the curve, guys, it's always 100%, which is 1. Okay. Now, to change a value from a raw value to a z-score, we introduced this formula in chapter 2. Z equals value minus the mean divided by the standard deviation. For example, guys, if I wanted to take 110 and use z-score to change it to 1, I could have done 110 minus 100 is 10, and divide by the standard deviation 10, 1, which is already 1 here, and so on and so forth. Okay, so this is the normal curve, guys, another visual, and this is the standard normal curve. You can see the label here is X, and the label there, guys, is Z. Okay, now here is what we're gonna do, some new stuff. He's asking us to use a table, which I'm gonna show you in a second, to find the area to the left of Z equals 1.15. Let me sketch this one first and tell you what we're trying to do. So he's using Z. We're gonna use 1, 2, 3, -1, -2, -3. He wants the area to the left of Z 1.15. So this is 1, this is 2. You guys should agree with me that 1.15 is here. And to the left, would you guys agree that to the left it's this area? All right. Here's my question to you. Can you guess the answer? Can you give me an approximation of the answer? What do you think the answer is? Just give me an estimate. Your estimate has to be more than 50%. Let me tell you why, guys. Because this is from 0 and down is 50%, and I shaded more than 50%, so it should be more than 50%. Any guesses? What do you think the answer is?
Would it be 75%?
75%. Any other estimates?
65.
65. Okay, let's see. You see, there is no way that you can figure this out by just guessing. Well, if it was from 0 downward, yeah, you can say it's exactly 50%. But 1.15, that's not going to be easy. If you remember in chapter 2, if we were at 1, we were able to figure it out. But now there is technology, there is a table, you can do anything. I can give you any number right here, and you will see how easy it is. The first way to do this, before I introduce the calculator, is using tables, and we will provide you with the tables. And actually, when you do your homework online, your tables are gonna pop up on every single exercise. However, before I start using the tables, I'm gonna give you the choice. You can use tables on the test or when you do homework on quizzes, and you can decide to use calculator, it's up to you. But I feel I should show you the tables because many of the help me solve this or view an example are based on using tables. So I need to show you the tables. But we will demonstrate the calculator as well. You're gonna love the way that this is done with the calculator. So in order to find this, there is a table called Standard Normal Distribution Table. It's right here. I'd like you to pay attention to it. All right. This table, guys, is designed to find the areas to the left of a z value. See how it's sketched right here, the visual? It's area to the left. So this area, it will calculate the area, and he wants the area to the left. So perfect match. Let me show you how to use it. He wants z, area to the left of z equals 1.15. You take, first of all, the ones digit and the tens digit of 1.15, which is 1.1. You locate it right here. Then you take the hundredths digit from z equal 1.15, which is 0.05, right here. Then you draw a horizontal line, guys, then a vertical line, and where the two meet will be your answer, and it's going to be right here. Do you guys agree with me that this is the case? 1.1 and then 0.05. Do a horizontal line, a vertical line, they're gonna meet at 0.8749, and that's your answer. That's the answer. Let me show you what I put there. So the one who says 75%, we're closer, and it's 8.749. Okay. Now, what's the area to the right of z equals 1.23? Let me sketch it. So 0.8749, that's the area. You can tell what this area is, guys. It's 100% minus this. Now he wants the area to the right of 1.23. Let me sketch this one. This is 0. Let's say this is 1.23, and that's what we want. Okay, let me take it to the table, and guys, and tell me what to do here. So we need this area. Any guesses? Do you guys agree with me that the answer is less than 50%? Yes, no?
Yes.
Yes, because I shaded less than 50%. Definitely it's yes. Well, let's see how much less. Okay, I'm gonna show you the table, guys. And I'm gonna have you brainstorm and tell me how would you do it. So 1.23, remember that. Here is the table. I will send you the tables by email, and they are available online anyway, but I will make them more visible for you. What do you think we should do, guys, to find the area to the right of 1.23? Remember, this table is designed to give you the area to the left of the target, not to the right of the target. But he wants the area to the right. Any ideas? Okay, something coming in the chat.
You can find what it is to the left and then just do 1 minus whatever that number is.
Perfect. Yes, that's the only way using the table. If you guys heard what she said you can find the area to the left of the target and then subtract from 1 the answer, because they should add up to 100%. So look what I'm gonna do, guys. I'm gonna find this area using table 4. It's called table 4. And then subtract the answer from 1. That makes perfect sense. Okay, what's the area? Let's do it. 1.23. That's a 3, guys. That's 1.2. And you just go this way. You go that way. It's 8907. So this is 0.8907, but that's not what I want. I want this, it will be 1 minus 0.8907. I hope that this makes sense, guys. It's just logic. It's not statistics, it's just logic. So it will be 1 minus 0.8907 will be 1.093. Okay, let's do another one. Again, guys, you will be introduced to some other ways to do it using technology, but let's finish the table part now, and then we'll do this. All right. Find the area under the standard normal curve to the left of z equal negative 0.99. Now negative numbers. It's right here, guys. And let me show you. You can see the answer is 1.611, but let me show you how to use the table to find it. So is there a table with negative values? Yes, indeed. Watch. Where is negative 0.99? So you need the negative 0.9 to begin with. And then the other 9. Where is the other 9? It's right here. Perfect. So it's going to be right here. 0.1611. And you can see, guys, that this is a 0.1611. That's the answer. Okay. Let's do a few more using tables, and then we will be using the calculator in a second. Any questions? You can interrupt me, guys, anytime. Please understand, if I hear no questions, whether this is true or false, I have to assume that everything is okay. We need the area to the left of z equals negative 0.47. Then the area to the right of z equal 1.28. Then the area to between negative 1.1 and 1.73. Let's do them one at a time. Area to the left of z equal negative 0.47. Remember, guys, to the left, you just use the table directly. So let me show you the table and tell me what the answer is. Negative 0.47. What would be the answer? Can someone read it? I can read it myself here. What's the area? Please don't be shy of participating. You can participate through chat. 3192. Let's see. 47. And it is indeed 3192. Yes, let me show you. You go this way and that way. They meet right here. 3192. Yes, that's the answer. All right. What would be the area to the right? Let's see the next one. To the right of z equal 1.28. So let me show you the other table. Positive values now. The table right here. 1.28, guys. Is it 1.28? Yeah. You need to use your calculator probably, because you're going to do area to the left and then subtract. So 1.28 gives you what? Right here. But this is not the answer, guys. This is the area to the left. You need the area to the right. It will be 1 minus 0.8997. So let me show you what I did here. So it will be 1 minus 8.8997. Any questions here?
You said you're going to post these online or scan them in, right?
Oh, yeah. You'll have the tables. The tables are already available online. I'll just point you out to where to find them.
Okay, thank you.
Yeah, definitely. And every single exercise you do in the homework, the table will pop up. It's linked, just in the exercise. So you'll have access to the table. But you guys, once you see the use of the calculator, you might decide that you want to use the calculator because it is much faster if you have it. Now, the next one, guys, which I really need some brainstorming here. He wants the area between negative 1.1 and 1.73. Let me sketch this and tell me how do you think we should use the table to do it. This is 0. This is negative 1.1. This is 1.73. Please participate with me, guys. You're not going to lose any points for participating. I know there are a few students who always participate, but I want the rest, guys. I do encourage you, please participate. Let's make it a live session. I get bored by just speaking myself all the time. Okay, what do you guys, we need to use table 4. Remember, that's the only table we have. Any ideas? How would you figure this out? Tell me what do you think we should do, and then I'll project the tables in a second. Think about it. Remember, the table does areas to the left. Any suggestions before I propose mine? Okay, I'm gonna write this. Area between z is negative 1.1 and z is 1.73 equals area to the left of z equals 1.73 minus area to the left of z equals negative 1.1. And let me tell you why, guys. Watch. This is area to the left of z equal 1.73. It will be this. That's not what I want. I want only up to here. An area to the left of negative 1.1, guys, it will be that. So if I do the big area minus this small area, I get what I want. So always the area in between is the big area to the left minus the other area to the left, and then you get the answer. So now I'm going to project the tables to show you how to find 1.73 and negative 1.1. Here is the table, guys. 1.73. 1.7 is right here. And 3, guys, is right here. So it's a 0.9582. Minus. Now we need the other table, which is the negative values table. I need to get you this one with negative values. And it's negative 1.1, guys. Negative 1.10 if you don't see a second, the 100th digit. So this is the negative 1.1. And the 0 is toward the end. Don't think it's right here. It's toward the end right here, the 0. So negative 1.1, if I follow it, it will give me 0.1357. You just subtract the answers and get the results. So this is what we did here. Now, let me just recap. Now, area to the left of z equal negative 0.47. You helped me out with this. It was 0.3192. But look how we can write that. An area to the left of a number is a probability, guys, when z is less than a number. So left of means less than. It's a probability of z less than negative 0.47. You know, guys, on the number line, you walk to the right, numbers increase. You walk to the left, numbers decrease. And you need to understand that the area is a probability. It's a percentage. It's a proportion. So when he tells you the area to the left of z equal negative 0.47, he's asking you to do this. This is called probability of z less than negative 0.47, which is that. When he asks you to find the area to the right of a number, it's the probability of z bigger than that number. So from 1.28 and up. And we did this using the table. We did 1 minus 0.8997, and it was 0.1003. If he asks you to find the area in between two numbers, it is the probability of z between negative 1.1 and 1.73. What we did, guys, we did the area to the left of z equal 1.73, and we did an area to the left of z equal negative 1.1. Some students in the past asked me which area to put first. I said, if you made a mistake, you're going to get a negative answer. Well, if you get a negative answer, swap the areas. So that means you put them in the wrong order. And the answer is 0.8225. Any question? This is how we use the table, guys. And now we're going to come to using the calculator. So I'm going to do the same 3 questions, but using the calculator right now. So if you have your calculator handy, please have it ready, because we're going to demonstrate how to use the calculator now. So we're going to do area to the left of z equal negative 0.47. All right, let me sketch it. You don't need to sketch it when you use calculator, but for the first time, I need to do that so you guys understand how the calculator works here. This is the negative 0.47. Remember, the tail doesn't end, guys. It extends forever. It goes forever this way. Okay. Here's what I'm going to ask you before we get started. This area, I want you to tell me what is its lower bound, lower limit, and upper limit. So how far does it extend to the left, and how far does it extend to the right? Can you read this number for me, guys? This keeps going forever. What would you suggest a value for this number right here? This is called the lower bound.
Infinity?
Yes, infinity, but from the negative side, right? It's infinity, but from the negative side, so it's negative infinity. Here is what I suggest. Calculator doesn't accept infinity, and actually you cannot express infinity anyway. So here's what I suggest. When you do a lower bound from the left like that, just put this number. Negative 1,000,000 or trillion. Just put with -1 with as many zeros as you like. What about the upper bound? Upper bound, it's the other end, guys. What do you think the upper bound is going to be? That should be easy. There is no limit from the left, but there is a limit from the right. It stops at what? Negative 0.47. It doesn't exceed that. The mean of this distribution, guys, is always 0, and the standard deviation is always 1. In order to use the calculator to find this probability, guys, you need to provide a lower bound, an upper bound, a mean, and a standard deviation, which you already did. So I'm ready to show you how to do this on the calculator. I'm going to use both calculators, the older one and the new one, and show you how that works. Right, side by side, turn them on, clear and clear. Okay. You go same thing as in chapter 4, second and distribute, and second and distribute. The good news, it's number 2. This is the one that you use to find a normal probability. It says normal CDF, and it says normal CDF, enter, and enter. Okay, you see, it's asking you for lower bound. We agreed we're gonna put -1 million. Okay, and then here I'll enter -1 million. Put a comma. Here, no need to put a comma, just press enter or scroll down. Upper, guys, we agreed it's -0.47. You're gonna love this, -0.47. Mean is 0 and standard deviation is 1 when you work with Z. Here you have to include it. Oops, I put dot a couple times. That would have been a mistake. Delete. Now it should work, comma, 0, comma, 1. Press enter here. And then scroll down here and paste. Here you go, guys, 3192, and that's what we got from the table. Any questions about this? That's how you do area to the left. When you do area to the left, begin with -1 million, put the Z value that he gave you, and then put 0 and 1, and you should get the answer. No need to use the table or nothing here. The second one that we did is probability of Z greater than to the right of 1.28. Let me sketch it, guys, and help me determine the lower and the upper bound. Okay, here's the next one. Actually, the in-between is the easiest one for students always. That's what I noticed. Okay, guys, what's the lower bound? What's the upper bound here? Can you tell me what do you think the lower bound is going to be? Okay, I see something in chat. 1.28, exactly. Makes sense. What's the upper?
Positive infinity.
Yes, so what would you want to use? There's no infinity on the calculator.
A whole bunch of zeros.
Yes. The more, the better, but it's up to you. Just put as many zeros as you want, and that should work. Okay, and the mean is 0 and the standard deviation is 1, guys, and watch. Let's demonstrate it. Go to second and distribute. Really does magic here. So lower is 1.28. Enter. I'm gonna put million, just enough. Even 1,000 would do it, because 1,000 is too far apart from 1.28, a z-score of 1,000. 0, 1. Remember, when you go beyond 3, you were talking about very unusual. So imagine 1,000 or 1,000,000. There you go. Now, probably you'll ask me to do I need to do 1 minus? No, because you're doing it the proper way. You're providing the correct lower and upper bound. You don't need the 1 minus. It's 1.003, and that's it. That was the answer. But if you use your table, yes, you have to do area to the left, because you couldn't do it directly and then do 1 minus. The next one, guys, which is actually, as I told you, students find it the easiest. Well, find the probability where Z is between -1.1 and 1.73. Let me sketch it. You don't need to sketch that every time you do a problem, but for now, I'm just doing it. Okay, can you tell me, guys, why this is so easy? Because we know what the lower and upper bound are. This is the lower bound, and this is what? The upper bound. As simple as that. You don't need 1,000 or 1,000,000 or negative 1,000,000. So let me show you. You don't need to subtract areas. You don't need to find areas to the left and subtract them. It's just one shot, guys. Watch. And you're going to get the perfect answer here. Normal CDF. Negative 1 point, what was it? 1.73, 0.1, paste, and 0.8225. There you go. Let me show you. So this is a summary of what I just did. I wrote them already down. And this is the area in between, negative 1.1, less than Z, less than 1.73 is normal CDF. You get the answer. Any questions, guys? And we don't use normal PDF. It's always normal CDF. This is the only feature that we use to find normal probabilities. Do not attempt to use a normal PDF. Cumulative density function, the CDF. What I would like to do with you guys, we're going to do the next exercise. And probably you can help me out with this. Okay. We're going to use technology now. He wants the probability. He gave you a normal curve, not a standard normal curve. As you see, he labeled the axis 500, 600, 700, etc. So it's not 0, 1, 2, 3. He wants the probability of X less than 600. Can you guys help me do this using technology? I'm ready. Normal CDF. We need lower bound. We need upper bound. We need mean, and we need standard deviation. In this order, guys, it's not up to you to change the order. What would be the lower bound? What would be the upper bound? Look at the blue curve, guys. What do you think the lower bound is? Okay, my chat is blinking. Negative infinity. How we're gonna write this down? So negative 1,000,000. That's good. And what's the upper bound? Yes. What's the mean? 500. Don't put 0, 1 here, guys. He's working with X now, not, you notice here, it's not the probability of Z. Once you see Z, put 0, 1, definitely. But if it says X, or he gives you a mean and a standard deviation, you cannot use 0, 1. 500, and then the standard deviation, he say it's 100. And look, let's do it. Turn it on. Second, and distribute. Normal CDF. Okay, so we have negative 1,000,000. Don't worry if you put some more zeros, it doesn't matter. 600, 500, 100, paste, and enter. And let me show you what I did here. There you go. Normal CDF, negative 1,000,000, 600, 500 for the mean, 100 for the standard deviation. It's in this order, is 0.8413. Now I have a question for you. Let's say you didn't have technology and you only have the tables and you need to solve this problem. How would you go about doing this? be honest with you guys, I start to allow students to use the TI-84 in this chapter just a few years ago, but prior to that, they used to do it, using table 4. So let's assume we want to use table 4. Your calculator is out of batteries. However, probably you can go online and download this app, which I will demonstrate tomorrow. How would you do this? Any ideas? You have the tables, which is good enough to solve this problem. How would you do it? I will pause for a second, just give you a chance to think about it. We can change 600 to a z-score, just like in chapter 2. So look, using table 4. Change 600 to z-score. Okay, what would that be? Value is 600 minus the mean, as you said, 500 divided by 100. Standard deviation is 100, guys. So you get 100 over 100, which is 1. So guys, probability of X is less than 600, which we don't have technology to do it just like that. We're going to change it to Z. So probability of X less than 600, guys, is the same thing as probability of Z less than what? 1, because the 600, I changed it to 1 as a Z-score. And this one, guys, which is probability of Z less than 1.00, I need the 2 decimals. I can do that on the table. Let me show you. 1.00. If it doesn't match with this one, guys, I'm in trouble. Probably I would quit if it doesn't match. Okay, 1.00. Here's a 1.0, here's the other 0. Can you see, guys? 8413. Perfect match. Now, will I require you on a test to do it this way? No, you can use calculator throughout. But remember, if you use X, you must put 500 and 100. If you use Z, you must put 01 when using the calculator. Any questions? Any questions, guys? All right. What time? How much time do we have still? Okay, we still have time. All right. There you go, guys. This is a demonstration on how to change it to a z-score. Okay. We're going to do this exercise together. Exercise 5. A survey indicates that people use their cellular phones an average of 1.5 years before buying a new one. The standard deviation is 0.25. So guys, the mean is 1.5 and the standard deviation is 0.25. So it's not Z, it's X. Once it doesn't say 0.1, it doesn't use Z, it's X. A cellular phone user is selected at random. What's the probability the user will use their current phone for less than 1 year? We need a probability. Well, it says, what's the probability? You write the letter P, open parentheses, you put X less than 1. Okay. Any ideas, guys, how to do this using technology? It's going to be the normal CDF. Okay, this is less than 1 right here. What's the lower bound, guys, and what's the upper bound? You don't need to sketch, you know that, but I did sketch it to show you how that works. What's the lower bound in here? Negative a million. What's the upper bound? 1. Great. Then the mean and the standard deviation, guys, 1.5, 0.25. Okay, let's do it. And that would be done. It's gonna speed up word problems, guys, tremendously once you use your calculator, because you don't need to change to z-scores or anything. It's just one shot. Watch. Second, distribute, normal CDF, negative a million. We already have it there. I should have left it. Then 1, 1.2. What was it? 1.5. 0.25. Okay, I got 0.0227. Let's change it to a percent, guys. It will be 2.27%. Is this usual or unusual for someone to replace their phone right before 1 year passed? Usual or unusual to happen? You might be asked this question. You're going to be asked a lot. Unusual because the probability is less than 5%. Unusual event because 2.27% is less than 5%. Anything that is below 5%, guys, is considered unusual to happen. And many of us who own cell phones know they wait a little bit longer than 1 year to replace it because they're very costly, but there are a few who don't, but their percentage is 2.27%, guys. One more question. Let's do this one together. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes. Once he says average, this is the mean, guys, so you can label that as the mean. With a standard deviation of 12 minutes, that's the standard deviation sigma. The length of time spent in the store is bell-shaped, normally distributed. Once he says normally distributed, you think of bell-shaped. All the math I'm teaching you today, guys, is based on the fact that the distribution is bell-shaped. If it's not bell-shaped, none of this would work. A shopper enters the store. What's the probability that the shopper will be in the store for between 24 and 54 minutes? I want you guys to help me fill in the blanks here. So what goes in the first check mark? Let's see what we have here. 24. That is correct, Julia. And then the second one is 54. You guys, it couldn't be any simpler than that. He already gave you the lower bound and the upper bound. So you just do normal CDF, and please calculate it as I do the math. 24 is your lower bound. 54 is your upper bound. Your mean is 45. Don't put the standard deviation first. It's mean and then standard deviation. Equals. Okay, let's do it. Second, distribute, normal CDF, 24. Oops. And then I have 54. Then you have a mean of 45, standard deviation of 12, and the answer 0.7333. Okay, let me ask you a question, guys, here. If by mistake you swap the 24 and 54, what do you think the answer on the calculator is going to be? Can you guess without doing it? Don't do it, but what do you think the answer will be? If you swap the, mix up the lower with the upper limit. Yes, very good. It will be negative. Then you know that you did something wrong. You can't have a negative probability. Okay, part B. Find the probability that the shopper will be in the store more than 39 minutes. So you guys agree with me that this is how you start, more than 39, you put 39 here. It's normal. CDF, and I need guys suggestion for the lower, upper, mean, and standard deviation. What's a lower? More than 39 means 39 and up. So would you guys agree that 39 is the lower bound here? For a greater, that would be the one, yeah. And what's the upper limit? No upper limit. The sky is the limit. So it's 1,000,000. Mean is 45 and 12. I hope that those numbers are making sense to you guys, because it's very important. That's the way to grasp this. Okay, so 39. If you put 1,000,000 or 10 million, guys, or 100,000, it's just going to be exact same answer. You can check. I got 0.6914. 15. All right, C. Let's pay attention to C. And then I can stop after that. And tomorrow we'll finish, we'll do more review. 5.3 should take about 20 minutes, but 5.4 is going to take me about 1 hour to complete. So we'll complete chapter 5 tomorrow. 5.4 is very, very important section. I will be running an applet on the computer for you to watch, and in order for you to grasp section 5.4 tomorrow. If 200 shoppers enter the store, how many shoppers would you expect to be in the store for more than 39 minutes? So if there are 200 shoppers, they want to figure out how many cashiers they should have on the floor, how many people are on the floor. So they need to know what is the likelihood that some of the shoppers will spend more than 39 minutes. We figured this out. It was 69.15%. Now, if 200 shoppers enter the store, how many of them, guys, do you think they're going to be there for more than 39 minutes? How would you figure this out? We already done most of the work. Yes, you multiply 200. I hear a student saying 200 multiplied by 0.6915. That is correct. And why we multiply the 200 by 0.695? Because 0.695 is the probability that the shopper is the percent that the shopper, or is the proportion of shoppers who will spend more than 39 minutes. So it's absolutely correct. So does it help to find this? Yes, definitely. And the answer will be 0.6915 times 200. Let me do this. And there's the answer. 138.3, you can make it 138 shoppers. See how important statistics is. So that is That's how you answer this question. Now, some students asked me in the past when I did this question, what about if you didn't have part B? Well, how can we solve this problem? Then you will find the probability that X is greater than 39 and then multiply the answer by 200. So he doesn't have to give you part B, but I put part B so I can flow in nicely, just to part C. Okay, that's it, guys, for today. As far as office hours today, I'm gonna just keep this running after you're done, and I'm gonna stop it at 2:30 because I have an appointment, a departmental meeting at 2:30 p.m. So I have, just to stop the meeting at 2:30. But I will be available from now until about 2:30, guys, if you have any questions. We're gonna stop the meeting right now, recording.